In this video, we will discuss the differences between rigid versus semi-rigid diaphragms in ETABS. Let's get started. We'll use this C-shaped structure to assign the rigid and semi-rigid diaphragms. First of all, we'll go to the plan view. We'll go to Define, Diaphragms. And we'll click Modify Show. Here, you can specify the rigidity of the diaphragm by choosing the rigid or semi-rigid option. These options affect only the analysis of the model. If the rigid option is selected, a fully rigid diaphragm is assumed. If the semi-rigid option is selected, the in-plane rigidity of the diaphragm comes from the stiffness of the objects that are part of the diaphragm. So we'll select semi-rigid, click OK, OK again. Next, to assign the diaphragm to the shell element, we'll select the shell, go to Assign, Shell, Diaphragms. We'll click the D1, click Apply. And now you can see the diaphragm has been assigned. In a moment, we'll run the analysis and take a look at some output. But first, let's discuss rigid versus semi-rigid diaphragms. So as stated before, rigid diaphragms have infinite in-plane stiffness properties, and therefore they never exhibit membrane deformation nor report the associated forces. But when a semi-rigid diaphragm is used, it simulates actual in-plane stiffness properties and behavior. So for most reinforced concrete slab systems in which the slab is sufficiently thick and membrane deformation due to lateral loading is negligible, rigid diaphragms produce results nearly identical to those of semi-rigid diaphragms, while taking advantage of faster computation. So, semi-rigid diaphragms should be modeled when significant in-plane deformation does occur, or when required by code. Floor diaphragms can only be assigned to elements in the same XY horizontal plane. Let's run the analysis. After the analysis is complete, we'll take a look at a deflected shape. Under Display, Deform Shape. In this case, we'll take a look at mode shapes. Now, we'll have to assign that rigid diaphragm to the shell. And we'll run the analysis again. Next, we'll go to Display, Force Stress Diagrams, Shell Stress Forces. We can take a look at different components, in this case, the maximum moment. A couple other notes about the primary differences between rigid and semi-rigid diaphragms. In relation to eccentricity, for rigid diaphragms, the accidental eccentricity associated with autoseismic loading is concentrated and applied at the center of mass, whereas for semi-rigid diaphragms, accidental eccentricity is applied to every node for autoseismic loads. And if no diaphragm is assigned, eccentricity will be applied to any node. In terms of reporting forces, in-plane, chord, shear, and collector forces are only reported when using semi-rigid diaphragms. In the next video, we will talk about how to extract in-plane, chord, shear, and collector forces.